In the last class, we have seen that structure of Lex program. So the structure of Lex program contains declaration part. Then after declaration, we'll be having translation rules part. Then auxiliary functions. In the declaration part, we have to give all the declaration, any variable which is needed to declare, and header file inclusion. That should be given with percentage opening bracket and percentage closing bracket. And then the translation rules part starts with percentage. In the translation rules part, we have to specify the pattern and action. Pattern, already we know how to specify pattern using regular expressions. So using regular expression, pattern should be specified. If pattern is matching, what action should be taken. That should be specified in the action part. Then end with the translation rules part. Then auxiliary functions. For writing the auxiliary functions, the C language should be used. Then like other C programs, the Lex program should be written with .l extension and will be saved. Then that will be given to the Lex compiler to convert into lex.yy.c, because the Lex program contains Lex code as well as C program statement. The Lex compiler, it will convert only Lex code into C statement. So now the lex.yy.c contains the converted Lex code into C format and other Lex C statements. That together it should be given to C compiler. C compiler will convert into a.out. For that we are giving input stream. We are going to get the sequence of tokens because as output. Because we know that Lexical Analyser output is sequence of tokens. So the token is going to provide as a output. This is an example program for Lex program to count the number of vowels and consonants. So our aim is counting the vowels and consonants. So in the declaration part, within the percentage opening bracket and percentage closing bracket, first header file will be included. Then vowels one variable, consonants one variable. Initially it will be initialized to 0. So now we can understand these three statements are pure C statements. Then after that we are having translation rules part that should be given within percentage and percentage. So within that, if in the reading that string, in that string any character matches with A, E, I, O, U, means that will be a vowel. So vowel will be increment. This is pattern, this is action. What this pattern is matching means vowel will be incremented. If it is not matching this, other than that any other letter it is matching means that consonant, it will be the consonant that will be incremented. So then next we are having auxiliary part, subroutine part. So the wrap class, that is one of the Lex function. Then that main, then printf enter the string, then YY-Lex mean the Lex part will be called and that will be executed after getting input. Then it will print the number of vowels and consonants. So this will be like a normal C statement. So now I think you understood the Lex structure of Lex program, declaration, translation rules and subroutine part. Now we'll see the YACC tool. Actually we have to discuss this one after the fourth module because of lab point of view. I am explaining now itself. So the YACC program, YACC means yet another compiler. It is also like Lex only, but it needs the output of Lex as input. So in that YACC program contains again declaration. In here, instead of the translation rules, you have to specify grammar rules because it is a grammar generator, syntax analyzer generators. This deals with grammar. So grammar rules should be specified. Then additional code should be specified. So in the declaration part again, that should be specified with percentage opening bracket and percentage closing bracket. All C declarations should be specified. Along with some YACC declarations should be there. That token declaration, that thing should be there. That's specified here. Then grammar rules should be specified over there. Then additional C code. This is the example YACC program to check whether the expression is valid or not. Arithmetic expression is valid or not. First we are having YACC part. Here there is no C declaration part. So YACC part we have declared arithmetic expression means expression we know it contains the operands and operator. That operands may be a number or it may be a identifier. So the token, two tokens will be the number identifier that will can be generated by the Lex program that will be given as an input. So percentage token this and operators plus minus star slash will be there. There you have to specify the associativity because one expression contains more than one plus, more than one minus, more than one and the same operator. So the associativity should be specified. Percentage left plus minus means left associative. Star slash also left associative. This specified. After that we are having the grammar rules part, then percentage. Here grammar rules specified expression equal to expression plus expression, or expression minus expression, or star, or slash, or expression may come within a bracket. For example, x is equal to bracket a plus b. Then expression that operands are maybe an identifier or it may be a number. Then finally it should end with semicolon, otherwise nothing. So then percentage. This should be given over the grammar rules. Then next is, if any error is there, row error should be called. Then main program. This is C program, C auxiliary code. So here printf enter the expression, is a pure C statement. Then y parse means that this y parse part will be called. Then parallel this will call the lex, and it will get the token from over there and will perform the operation. So this is structure YACC program. Then now you should know how to execute the YACC program, because that YACC program input is token. Who is going to generate? Lex is going to generate. So the YACC program contains Lex part as well as YACC part. So here first the Lex program should be written with .l extension and should be compiled with Lex compiler, and YACC program should be written with .y extension, then it will be compiled with YACC compiler. Then both will give the output as C code. So then both the program output program files together, it will be compiled with C compiler. That's the reason we are going to give cc.lex.yy.cs output of C lex, and y.tab.cs output of YACC. Then both will be combined. Then we are going to get the output as ./a.out. For that we are giving input, we are going to get the output. So like this you are having some more Lex and YACC programs in your lab. Please go through that and execute it. Then you will get clear picture about Lex and YACC. Thank you.